In this video, we're going to use Excel to solve a regression problem and answer to the question from A through H. Now, the problem is trying to model to predict the asking price. So this will be my Y value, YIs. And they're going to use the size of the houses as basis, right? So this will be the X values, right? Now, the first question is to identify what would be the B0 and B1, the y-intercept and the slope for the regression line, and select the corresponding graph. All right, so let's get into Excel. First of all, you need to download your data. And you go to this window here, double window, open it, and open in Excel. So once you get the download, you open it. Make sure to enable the editing mode. And the first question is to do the scatter plot. So again, let me remind you about the X values. We can insert one more cell here, or we can write it inside. So the asking price, that will be the Y values, and the living space, it will be your X values. Okay, once we identify the X and Y's, we need the scatter plot. So I'm gonna go to insert. I'm gonna click on the chart. Please, this is really important to click outside of the graph, otherwise you're gonna take it by default. So we want an empty scatter plot. So somewhere here, right? And then you click on scatter plot and select the first one. We wanted to have scatter plot always empty, and then select our data. So right click, I'm gonna select the data, and in here I'm gonna add a series. In the series, you don't need the name, you just need the value of the x's and then the value of the y's. So click on this one and select the value of the x's. Do not select the labels, so select all the way down. And similarly, I'm going to do for the Y values. So here, make sure that you eliminate anything in there. Click on the small box and select the values. So the number of values need to match. So you have to scroll all the way up to double check that you selected the first one. Okay, it looks great. Then okay. Then okay again. So this is my scatter plot. Right, so let's go back to the exercise and see which one is similar. Currently this one, so let's expand it, and it looks pretty much similar, right? Okay, so that's the one that we're gonna select. That B. All right, next question. They want to identify the A at the B0 and B1. So there is a way to get it here, which is click on the points, right click later on, and add the trend line. And you're gonna display, make sure you are in linear. This is checked, linear. And display the equation on the chart and display the R squared. So you can see them here appearing. And then you can select all of them, select and make it bigger letters. You can read them. Okay, so now it looks nice. However, this is not good for us, not good enough at least. And the reason is asking us to round to 3 decimal places, and you see the B0 is only 1 decimal place. So I need more precision with this. So here I need to run my data analysis test. All right, let's get into it. So the data analysis test, you have to go to data, then data analysis here. Make sure you select regression is all the way almost on the bottom. Then okay. Now they're asking for the Y value first. So click on the small box, the y value is right here, so you can select all the way. And then you're gonna do the same for the x values. You could use shift, control, and the bottom arrow down, 3 together, and that will select everything. All right, that's in case you are in Windows. Right, now I'm gonna check whatever might ask us. So the labels, definitely. For the output, I'm gonna select the first one, output, on the same worksheet. And then I'm gonna select a cell where I want my data, and then I'm gonna add to this the residual plot. Right, so usually they ask us about residual plot, and say okay. All right, so let's expand this table a little bit. Okay, so you can see here we have the x-intercept is right here. We can change the color, and the m is right here. So this is B0 and this is B1. All right, so what I can do, I can just copy them, copy B0, Control C, go to the exercise and put it into the y-intercept, the cell without the x, and Control V. And you can round it here to whatever you like. So 3 decimal places, you can be 1953, so 195. And I do the same thing for this value, B1, Control C, then Control V, and round it to 3 decimal places. So we have 0696. So this is going to be, instead of 69, 70, right? Okay, let's check it. Now, in this question, they wanted to make interpretation of the meaning of the y-intercept and whether it is good, is appropriate to use it or not. And obviously, if you look to the table, the y-intercept means the living space is 0, and we don't have any living space 0, right? So this is on the value here, I don't see any living space 0. So definitely is not appropriate to select it. So it's not appropriate to interpret the y-intercept because the house cannot have an asking price of 0. Not asking price actually is the range of observed data. So you would be more likely C. It's not appropriate to interpret the y-intercept because it is outside of a range of the observed living space. I think that's the right one. Okay, that's good. And the interpretation of the slope, what's the meaning of the slope? So the slope here, we got 0.069. So that's the amount that you're gonna increase for each square feet. And you can see here the asking price in thousands. So this is the price, how much you can increase in thousands, right? So thousands of dollars basically is $70 every square feet, right? So the slope indicate for each increase of 1 square foot, the predicted asking price estimated. Yeah, so it's not decreased, gonna have an increase, so the slope is positive. $1,000, K times B1. That should be the right answer. Okay, good. Now, in this question, they want you to predict a 2,000 square foot house or area. So what we're gonna do, we're gonna use Excel to do this. So I'm gonna put the X values, small table, create small table here. All right, so here you're gonna be the X values, and I know what is the value. Well, it's fine, 2,000. And right here you're gonna be the living space, the Y value. All right, and put it here as an equation. So you start a function mode, equal sign, and then you're gonna click on the B0 plus B1 times shift and 8 and multiplied by 2000 here. Click on the 2000 and enter. And that's the price. All right. And the formula that we used here is obviously this one. Let me write it down for you. So the y equals to b0 plus b1 times x. Okay, so the number is this one. Let's copy it, plug it in, and they want to round it to the nearest $1,000. So 494.4, that's going to be 494. Okay, let's check it. Good. Now they are talking about r squared. So with the r squared in our chart here, you see the r squared is right here. So this is where the r squared is, they are asking us about this value, and the value is 0.29370294. So now, what the meaning of the r squared? The r squared is the percentage of the variation of the y that is explained by the x. So if I see it here is 29% only of the price, all right, is explained by the area. And that's what I'm looking for. So either proportion, definitely not a probability, so you can ignore the two statements with probability. So proportion here of variation in living space, no, we are looking proportion of variation in asking price, that the y value that is explained by the variation of living space. So definitely this one. And right here we're gonna write down the r value. So it's gonna be 0.294. And you notice here in this question we did not have any approximation, didn't mention, so please approximate it to 3 decimal places. If you do 4 decimal places, probably the system will count it as wrong. Let's check it. Okay. All right. So here we are talking about the residual plot. All right. And if you notice, remember we selected it already. So this is the residual plot chart. You can expand it, and that's how it's gonna look like. All right, so definitely there is no pattern, and that's what we want. We want like the distance more or less they're the same. No points we are far away, no pattern, and that should be a good plot. All right, so now we're gonna fill up this. So the residual plot shows here it should be no pattern, and the spread should be roughly equal spread. All right, the plotting of residuals in collection order is not necessarily a normal probability plot of the residual suggested. That residual are roughly, no, are not here, so are not normally distributed. The fit of the model is adequate. So the fit is adequate, and this should be the selection that you should do. Let's see, no, there is one wrong at least. All right, so here it should be roughly normal distribution. For question F, we are using the hypothesis testing to determine whether the B1, beta 1 actually, is a good choice or not. And for this, you are given already in the book, the hypothesis testing, it is always the same, never change. So the A0 is beta 1 equals 0, and H1 is beta 1 different than 0. And in order to get a linear relationship, you need to have H1. So you need to reject this. You need to have a rejection, so sufficient evidence to reject it. All right. So now the test that we're going to be using always, or it is used on Excel, is this test, the test t-test, and this is the value of the test statistic. You don't need to calculate it. Excel is providing this value for you. And then we're gonna make a decision by comparing the p-value to the alpha value. And usually if the p-value is smaller, you reject. And remember, that's what we want, right? We want to reject 80. So this is your formula. And you wanna make sure this is valid. Okay, so let's go back to the question. Here we are selecting beta 1, and here it's gonna be equals to 0. That's 80, and this is beta 1 different than 0. That's the first part. And they are asking you for the t statistics, and it's given by Excel. So we care only about this part in here. So on Excel, the t statistic that we are taking for the x values, and this is the value 3.7. Copy it, paste it, and round it. And you want to round it to 2 decimal places, so it can be 70. Now they are asking for the p-value again for the same variable, and the p-value is right here. Copy it, paste it, and you want to round to 3 decimal places. So 3 decimal places again be the 7, and turn the 0 into 1. That's it. And what you want to notice here, that the level of significance is 0.05 right here. So that's what we're going to compare. We're going to compare the p-value to that value, alpha value. Okay, great. Now we're going to make a decision. So here, the p-value, you just need to make sure that this statement is true. So 0.001, and this is 0.05, I think. Let me double check. Yeah. So obviously the alpha is greater, so the conclusion reject 80. So now, if this statement is false, we do not reject. So we can accept H1 basically, right? So just make sure this is true statement. Okay, so here we are reject 80, and every time you reject 80, there is sufficient evidence, otherwise you cannot reject. All right, now we want to construct the 95 percentile confidence interval, and again this is given to you by the data and is right here. So this is the confidence interval. You have the lower and the upper level. So those are the two values that we're gonna plug it in, right? Okay, so the first value is gonna be 2 decimal places, right? It can be 0.03, and the upper value, this is gonna be 0.107, so 0.11, right? Let's check it. Be good. And here the conclusion, what is your conclusion reach, whether there is a relationship or not. So looking at the graph, definitely there is a relationship. So I'm not talking about residual, I'm talking about this chart. So there is a relationship. All right, the issue is the r squared is really weak, is 0.29. so although there is a relationship, but that relationship does not explain everything. So we are missing more factors. And the good statement, so there is a positive relationship and there is a negative relationship. So because the slope is going upward, there is a positive relationship. However, it cannot be stated that a larger living space cause a higher asking price. So we cannot make that statement because of the r squared. And that's it.